Hey everyone. So this particular lesson we're going to take a look at uncertainty, significant digits, basic measurements in science. So this is math with the very basic language that we use in science. Nothing high tech about this, but this is the basic vocabulary that we need to know. So let's jump in. Hello class. So let's take a look at what this whole measurement thing is about. This is nothing fancy. Here is just a very basic ruler. What I would like you to do is take a moment, 5 seconds, a minute, however long it takes you, and I would like you to make your best guess as to the measurement of this blue line. So I want you to write down your answer as if you were going to turn this in for a grade. I want you to pause the video in just a moment and then start the video back again once you have your answer. Go ahead and pause the video now. Alright, I will assume that you did what you were supposed to do. You paused the video, you came up with an answer, and now you are back. So now together, you and we're going to work through this and we'll see if your answer matches up to what I have. So first of all, your answer should be somewhere between 7 and 8. Obviously it's less than 8 but more than 7, so your final answer should be 7 point something. Alright, so far if you've got that, you're good to go. Now we have to look at this and we realize that right here that there's a certain number of lines here that can be measured. So we've got 1, 2, 3, 4, 5 gets us halfway between 7 and 8, and that makes sense. 6, 7, 8, and then we notice that that blue line seems to be somewhere between 8 and 9. So before we do anything else, we realize that we're probably, the answer is somewhere between 7.8 and 7.9. It's somewhere between that. It's not on this 9 mark, so we can automatically realize that that shouldn't be an answer. So our final answer should be 7.8 something. And the reason I say something is if you look very closely, and I'm hoping a bunch of you already figured this out, I'm going to zoom in for you. If you zoom in, you realize that this blue line is between the 8 and the 9 mark. Okay? So that means it's greater than 7.8, but less than 7.9. So we have to make what we call an estimate. We have to make a guess as to what that number is. So let me, before we actually do this, let me back out of here. Let's go to this next part. What we have is a situation where we know it's 7.8 and then some value that is greater than 0. If it was directly on that line, we would say 7.80. But what we have is some uncertainty. We are uncertain as to exactly what that answer is. So what we have to do is we need to come up with a value that has meaning for this measurement. All right? And so what we call that is uncertainty. So if we think about it, we have to put a digit here that is somewhere between 0 to 9. All right? Somewhere between 0 to 9. And the reason why is if it was directly on the line where the 8 was, we'd say 7.80. If it was directly on the line where the 9 was, we would have said 7.9. If we go back, remember, we're dealing with the metric system. So what you immediately, if you have an answer that was in inches, your answer is wrong. If you said anything with fourths or sixteenths or halves, whatever the case might be, that is wrong because we do not use this bottom part here. This bottom part here is what we call the British Standard System. All right, this is the British Standard System. The entire rest of the world uses this metric system as a standard, and which is why science uses it as a standard as well. So keep in mind, just because both of the type of measurement units are on one ruler, one tool, doesn't mean you use whichever one you're most comfortable with, or doesn't mean that you even use this one. You're always using the metric system. All right. So now with that said, we have to come back here, and we need to figure out what is going on. We are uncertain. So we have to make a guess right here. And so another way, this has to be between 0 to 9. This is what we call an estimated digit. You're going to make an estimate. This is going to be your estimated digit. You have to make a really good educational guess as to what the value of that number is. And here's how we do that. Okay. So let me zoom back in. And we look here, and you could on your paper, you may not have the zoom feature like I have, but you can look at it, and you could very well see that the edge of this blue line does not go directly halfway. The halfway mark is about right there, where that blue dot is, and it's less than that. All right. If you look closely, if you've been following my cursor, all right, you'll see where I've got that blue dot. That is around halfway in between. And we would mark that point right there 7.85 because, again, we're in the metric system, which is base 10, right? This should sound familiar. You've been exposed to this in elementary and middle school, but I'm very much aware that this is a skill set that many people it doesn't stick with you because, especially here in the U.S., we don't use this on a very regular basis, and so most people aren't comfortable with this. This is part of the reason for this lesson. If you are comfortable with it, then that's great. You're going to be able to breeze through this without a problem. All right, so we need a number that's less than 7.85. Looking at that, we might be able to say something like, say, 7.84. All right, there may even be an argument, say 7.83. So, but right now, let's go with 7.84, and we're going to come back to the whole 7.83 here in a second. All right, let me zoom this back out to where we were. So right now, remember, we are trying to figure out what this value is right here, and right now we are guessing that it's a 4. So I'm going to come back over here, and I'm going to write 7.84. That is my estimated digit. All right, I know that is my estimated digit. All right, let me go ahead and get this stuff out of the way. That's the estimated digit, 7.84. But 7.84 what? All right, well, if you look over here, we see that there's millimeters. And so if you wrote 7.84 millimeters or 7.8 millimeters, that is still wrong because a millimeter is each of these one lines here. So there are 10 millimeters in 1 centimeter. So this is 1 centimeter, this is 2 centimeters, this is 3 centimeters, and so on and so on and so on. And so what we now know that the best answer for this is 7.84 centimeters. Okay, 7.84 centimeters. Now, so not conversely, but alternatively, let's think about this. If there's 1, 2, 3, 4, 5 millimeters. There's 5 millimeters, 6, 7, 8, 9, and then the 10th one gets us to 1. So that's 10 millimeters. So 10 millimeters equals 1 centimeters. Well, we could very easily see that, well, here's 10, 20, 30, 40, 50, 60, 70. So there's 70 millimeters. Well, we could see that essentially if 10 millimeters is 1 centimeters, then we could also say this is 78.4 millimeters. Either one of these answers would be a good answer. We're going to stick with this one because we tend to just do things in our life with more standard larger units. Like I don't say, hey, would you walk 37 feet uh, in that direction in the room? We don't speak that way. We don't say, hey, I'm gonna drive 42,820 feet and then I'll pick you up. We just say, hey, I'll see you I'll pick you up in a few miles. There's over thousands of feet in a mile. There's over 5,000 feet in a mile, right? So we just basically speak in miles and say, hey, I'll pick you up in about 3.5 miles. All right, we do something like that. So instead of saying, hey, how tall are you? Well, you're 72 inches tall. We say you're 6 feet tall. All right, so for that reason, here that should make sense while we're going with 7.84 centimeters. Okay, 7.84 centimeters. So our uncertain digit, our estimated digit that we're uncertain of is right here, and you should notice that I want you to take note that this is the 100th place. There's the 10th. There's the 100th place, and that's going to be very important for the next thing that we're going to be talking about here, right? So uncertainty. Now, when you're uncertain mathematically, let's go back to what we had here. 7.84. All right? Or it was 7.8 something, right? It was 7.8 something. We didn't know what it was, but we just knew that it was 7.8 something. All right? We just knew it was 7.8 something. I'm just bring this down here. Okay. Let me erase this. While I'm doing this, I just got an idea, which is why I'm moving that down. All right, 7.8 something. So now, when we were talking, we said, hey, this thing could be 7.84, or it could be 7.83. The question was it a 3 or was it a 4? Now, I arbitrarily chose 4. I could have chosen 3, and I want to show you that when we're dealing with uncertainty, what we mean is sometimes your answer can be a little bit greater or a little bit less. And in math class, you've talked about this concept because you've written answers as plus or minus a value. So what we have to do is for uncertainty, what we have to do is figure out what is the plus or minus value for this tool that we are measuring. Okay, so uncertainty it's easy to figure out. Uncertainty equals the smallest scale value. All right, smallest scale value times 20%. Now, where does the 20% come from? It is a mathematical arbitrary number, not necessarily arbitrary. Mathematicians, scientists, it's a standard that has been that is based off of when we make a tool. There is room for error. So, and it's been calculated by a mathematician. So if you think about it, everyone, I don't care if we're on this scale up here with the metric system or down here with the British standard system, there's space between each line. But we had to make machines that put those lines in those exact places. Now, if we think about it, the closer we get to those lines, there is error. So anytime we make something, there is the possibility of error that one of those lines is a little more over to the right, which we would think of as greater, or a little bit more over to the left, which we think of as being negative, right? A negative value, being less of that value. And so there's always a plus or minus value to this estimated digit, which means we have some uncertainty about this value that we just assigned as 7.84. So this 20% mathematically helps us figure out if our answer, what's the range of our answer that might make sense. So let's go back here. I'm sorry. Smallest scale value. We need to figure out what that is. You look at your tool, and you figure out what's the value for one of those lines, just one. One of those lines is the smallest value that you could measure on this scale. So if we think about it, if this is the value of 1, and halfway right here would have to be 0.5, which means that's 0.4, 0.3, 0.2, 0.1. So the smallest scale value for this particular measuring device is 0.1. And I'm going to write 0.10 because we tend to write extra numbers in what we have. And that's going to make a lot more sense with some other lessons here in a second. But it's also going to make sense with this lesson coming up right here. And remember, that's 0.1. That's 1 millimeter, or that's 0.1 centimeters, right? And then now we have times 20%. All right, so now your math teachers, you should see this is just looking like a basic algebra problem. And we bring down what we already know. And if we want to, we can put all this in parentheses to help separate it out. I know your algebra teachers have shown you stuff like this, your math teachers. So 20%, you know that whenever you multiply by a percentage, you have to take it out of percentage form back into a decimal form. So it would be multiplying by 0.20. And we say 0.20, but you always write your placeholder. Just don't write 0.20. Make sure you write 0.20. Okay? So now you've got 0.1 times 0.2. Well, that should be, it's no secret that you've got 2 times 1, which is 2. And you've got this value and this value. So you have a total of 2 places after the decimal. So your answer obviously should be 2 places after the decimal. And if you punch it in the calculator, you'll notice that you get 0.02. And then you bring down that unit right there, centimeters. And remember, uncertainty is whether or not it's plus or minus whatever this calculated value is. So our uncertainty for this tool that we're working with is plus or minus 0.02. All right, so now let's think about this. Let's think about this for a second. We said 7.84, but I said we could have said 7.83. So what that means is if we're plus or minus, so the best final answer now we know is 7.84, hang on a second, plus or minus 0.02 centimeters. This is actually the best answer. Okay, this is the best answer. Now what that means is this. So let's take 7.84 centimeters. If we were to take 7.84 and we were to add 0.02 centimeters, we obviously get 7.86. So that means our estimated answer could range as high as 7.86 centimeters. If we were to take 7.84 and subtract 0.02, then we get 7.82. So our value could range as low as 7.82, and we would say it could be acceptable. All right. So now here's where we go with this. We ask ourselves. Let me zoom back in. Remember how we said that right there, that middle part. This thing is less than where the 0.5 is, and I estimated 0.4 because I estimated higher. So if we go back to it, we can see that, well, if that halfway mark, that 0.85 is right there, it's definitely not 0.86. So that's definitely would be a bad answer. 7.85 would be a bad answer because we can see that it doesn't reach the halfway mark. 7.82 is also probably not a really good answer. It's possible if there's a lot of error in the way that this thing was made, but it's not probable. So that's why, since I've done this before, that's how I kind of knew that a really good answer was 7.84 or 7.83. So, but technically, if we had an answer that ranged somewhere between these, we would call it good. So, if we were on a quiz or a test, what would be an acceptable answer would be 7.83 centimeters or 7.84 centimeters. Either one of those two answers would get you a correct answer on on a test or a quiz, some sort of assessment. But 7.82 or 7.86, as you can see from the ruler, is just way too high. So what that means is you made a really bad estimate and you didn't think about it as deeply as you could have. Okay? So hopefully that helps with that. Let's practice one more problem. Okay? I want you to, in just a second, pause this video and then calculate the uncertainty for this problem, and then unpause the video, and then let's see what you've got. Go ahead and pause now. All right. Let's see what you got. I'm just going to go ahead and work out the problem, and let's see. And so what I'm about to do, if you have everything on the screen that I have, then you know you are correct. So uncertainty. Whenever you have an equation, you always write the entire equation first. All of it. No shortcuts. So the smallest scale value times 20%. All right, times 20%. All right, I'll choose a different color here so we can see what's going on. It doesn't matter where you measure here. It makes no difference where you measure here whatsoever. Okay. You can measure from the 150 to the 200, 200 to the 250. It really doesn't matter. Let's just pick one of these. Let's just go down here. If this line here is 50 and this line here is 100, you could easily see that this is 75. Conversely, right here, if this line, not conversely, but also to compare, if this is 100 and this is 150, this is the halfway mark. Obviously, this would be 125. If this is 200, this is 150, this is obviously 175, and so on and so on and so on and so on and so on. Okay. So what you do is you assign a value for each of these lines and you count by that value. Whatever that value is, if we're correct, by the time we use that value for each line, we should get to 75 or 125 or whatever the case might be. So here's 50. If we count each of these as 1, it'd be 51, 52, 53, 54, 55. So 1 is not it. Okay? So we have to count by a value that works, and you should be able to see that 5 probably is going to be useful here. So here's 55, 60, 65, 70, 75. So the value, the smallest scale value for each of these lines is 5. And you should know that you should recognize this is a graduated cylinder, and that means 5 milliliters. All right. So our smallest scale value is 5 milliliters times 20%. So now we've got 5 milliliters times 0.20 because that's pretty bad, because we've got to take it out of percent form and put it in a decimal so we can mathematically actually use it, right? So if you look at this, you should be able to see that, okay, well, you've got a 5 and you got a 2. 5 times 2 is 10, right? All right, so we've got 5 times 0.2, and if you put that in, if it was 5 times 2, it would be 10, right? Well, here, what we've got is times 0.2, 20% of it. All right, it's like 1/5 of it for the most part, right? So, I lost my cursor. There it is. So if you punch it in the calculator and think about the math of it, you come up with 1. We should write 1.0, however, though. All right, that's a really ugly 0. That's better. The unit is milliliters. Sorry. We're calculating uncertainty, which means that whatever final answer you have, it has an uncertainty of plus or minus 1 milliliter. All right. So let me give you an example. Let's do an example of this. You fill this up with water. Oh, that's pretty bad. So you fill this up with water. Oh, that's really bad. Trying to draw that whole meniscus thing. All right. So I'm trying to get this. Wow, that's really. We'll go with that. Why not? Okay. Don't want to waste your time too much. So pause this video and tell me what you think the value was. Pretend that down here, all down here is this is filled with some sort of liquid. Let's just call it water. All of this down here is water. Pause the video and give me your best final answer for that water line. Right, this water line right here that I drew. All right, pause the video, come up with an answer. All right. Hopefully, so let's think about this. 200, the halfway mark, this would be 225, right? So you know that your final answer has to be greater than 225 milliliters. All right. So now you can see that this meniscus, and you always measure from the lowest point, and you can see it's not touching that line. If it was touching that line, we would say 225. You can see it's slightly above it. All right, you can see that it's slightly above it. It doesn't look halfway between this line and this line. So, but it doesn't look exactly close to this one. I would think 227 milliliters. Okay. Now, let's think about this for a second. If we know for this tool the uncertainty is plus or minus 1 milliliter, if you wrote 226 milliliters, give yourself a point, because the value, the range of this was plus or minus 1 milliliter. Okay, it was plus or minus 1 milliliter. There's a possibility that you may see it as being just a little bit lower than what I'm seeing it. There's also a possibility that you might think, well, 228. So if you had said 228 milliliters, it's possible. It's possible. I would not necessarily choose that one. I would choose this one or that one, because if you think 228 means you're really close to this next line here, which is 230, right? 230 milliliters. And this is a lot lower. Remember, you always measure from the lowest part. All right, remember that lowest part. You were taught this in your biology classes, is the meniscus, right? It's the lowest part of the water line. And later in class, we'll talk about why the meniscus line for a lot of liquids curves downward like that. But some meniscus lines for certain fluids actually curves upwards. And we'll talk a little bit more about that. And maybe your biology teachers actually explain that to you. That would be great if they did. Okay? So 226 or 227. I would go with either one of those. And notice that the plus or minus 1 milliliter that we've chosen, we can come up with an answer that is within a range of about 1 unit. That's a really good estimate. Notice that the 1 is in the ones place. Notice that the 7 or the 6 is also in the ones place. This is 1, 10, 100, right? Let's go back up here. Let's take a look at this. Notice right here, 0.02. This right here, that place right there, that's our 100th place, right? That's our 100th place. And notice that our estimated digit was right there in the 100th place as well. So whenever you calculate your uncertainty, the value that you get in your plus or minus value, it's always in the exact place where you are estimating your digit. If it's not, then that's evidence that you did your math incorrectly, and you may want to step back, and take a look at what you did and rethink what you're doing. Okay, it's a way you can always check yourself. Okay, so in this video, we've done a lot, It's very simple stuff, but trying to just retrain your brain on how to think about math, particular to how we're going to be using math to analyze things in chemistry, right? So I just started off with a basic ruler. And uncertainty is a new topic for you, but plus or minus values are not new to you. This equation, the uncertainty value, that's never going to change. That is always going to be it's always going to be that way. That equation is never going away. And then we just had this little practice problem here. Okay? All right. Hope that helped. Check out the different places in the video, the timestamps, if you need to go back and take a look at what we've done. Practice and review. It's here for as often as possible. All right. I'll see you in the next lesson. All right, so I hope that helped. I hope you have a better understanding about how to use numbers in a very basic way in a chemistry class. Nothing very complex, but if you need to, watch the video multiple times over and over again. I'm always available to ask questions. It's good seeing you. Take care. Bye.